These are probability notes 10, binomial probability distributions. So today we're going to review what a binomial experiment is, and we're going to solve binomial probability problems. We're going to look at an example of playing a game of rock, paper, scissors. The probability of winning a round of rock, paper, scissors is 1 out of 3. You got rock, paper, scissors, 1 out of 3 chance of winning, 2 out of 3 chance of not winning. Now there's a 1 out of 3 chance of losing and a 1 out of 3 chance of tying. We're going to consider this to be a binomial situation because you can either win or not win. Now not win means you either tie or you lose, but there are two possible outcomes here. And remember, in a binomial experiment, binomial stands for two possible outcomes, success or failure. Either you win or you don't win. Also, we have independent trials. Each trial has the same probability of success and a fixed number of trials for each experiment. We're going to do an experiment where we're playing 4 games against an opponent, and we're looking for the probability of winning exactly one game using the NCK, P to the K, Q to the N minus K formula. Let's see if you remember how to solve this problem. See if you can work out the formula, crunch the numbers out. We'll see what you get in just a moment. So in this scenario, N is 4. That's the number of games we're playing, or the number of trials. There's 4. K is the number of successes. We're looking for the probability of winning exactly one game. So 1 is our K value, our number of successes. 1/3 is our probability of success. That's P. Q is 2/3. That's the probability of failure. 1 is our number of successes. And N minus K, 4 minus 1, is this exponent. When you actually crunch this out, you get 0.395, so about a 39.5% chance of winning exactly one game. Now there is a calculator shortcut that you can use as well, and it's going to involve using this binompdf command. You can find this on your calculator if we turn your calculators on by going to the second vars menu. You'll see a little DISTR here kind of by the down arrow. So we're going to go to second vars, and if you scroll down a little ways, you will see an option that says binompdf. Binom stands for binomial, P stands for probability, D stands for distribution, F stands for function. This is a calculator shortcut of getting the same answer that we just did. So what I'm going to do is I'm going to go to second vars, binompdf, and the values that you plug into this command are going to be N, the number of successes, comma, your probability of success. Now if it's a fraction, you can type in 1/3, or you can type in 0.3 repeating. K is the number of successes, that's 1, and we hit enter, and you get 0.395, the same answer that you should have gotten using the other method. Now if you have a newer calculator, it may say a little different menu option other than this, but you're still going to plug in the first number as your number of trials, the second value is your probability, and the last number is your number of successes. So it should work out just fine. So we will write down this command on your paper as well, just to remind you what values you're going to plug into your calculator when you do this. Now when it says construct a probability distribution, remember a one-word definition for probability distribution is a chart. So we're making a chart of all the different values that could happen when you play 4 games of rock, paper, scissors, and X is the number of games won. If you play 4 games, the least number of wins that you could possibly have is, well, 0. And the most number of wins you could have is 4. And you could win any number of integer games in between 0 and 4. Now we've already calculated the probability of winning exactly one game. That's about 39.5%. To find the probability of these other events, you can either use the formula that we talked about last time, or you can use the calculator shortcut. What I'd like you to do is I'd like you to figure out the probabilities for each of these other values. You can use the shortcut, which basically is this formula, replacing the K, which is your number of successes, or you can use this formula, which is a little bit more involved. Either way, see if you can figure out these values. We'll pause the video and we'll see what you get in just a minute. I've shown a couple of the answers for this problem. For 0, for a probability of 0, that probability is 0.1975, so I'll say 0.19, that would round to an 8. For 2 wins, that would be 0.296. Now a shortcut that you can use to solve these problems a little bit quicker is you can go to second, enter, and then all you have to do is replace the number of successes. So to get 3 successes, I can replace the 2 with a 3, and then for 4 successes, I can replace the 3 with a 4. And you can see the probabilities I get for 3, it's 0.0987, that would round to 0.099. And then for 4, it would be 0.012. It's kind of fun. You get 0, 1, 2, 3, 4, 5, 6, 7, 9. So this is your probability distribution. You should understand what a graph would look like. We're going to do a little histogram of this information. So make a nice histogram of this. We'll come back and we'll wrap up with the last few probability questions when you're done. Remember, when you're making a nice probability distribution graph, we do want to label the horizontal axis with X, the vertical axis with P of X, which is your probability. And then we'll have our bars going up to about 20% here for 0, almost 40% for 1. We'll go up to about 30%. And then for 3, it's only about 0.099. We're talking about 10% roughly. And then for 4, 0.012, that's about 1%. So a very small graph right there. There's your probability distribution. Our last couple questions is asking about probabilities of winning not exactly 1 or exactly 2 games, but at least 3, at least 1, and no more than 2. Winning at least 3 games means 3 or more. So to calculate this probability, what we're going to have to do is we're going to have to add the probabilities for 3 and 4 together. So the probability of 3 wins is 0.099. The probability of 4 wins is 0.012. And we're going to sum those values together. At least 1 game is the same idea. It's 1 or more. And no more than 2 means not more than 2. Not more than 2. More than 2 would be like 3 and 4. We don't want more than 2. We don't want 3 and 4. We want 2 or less. So what we're going to look for here is the probability of 2 or less. So figure out what probabilities you're going to be adding together to get these results, and we'll see if your values are correct. Crunch out your final answers for these 3, and we'll take a look at your answers in just a moment. So the probability of winning at least 3 games is equal to 0.111. Winning at least 1 game is what you get when you add the 4 probabilities in the chart for 1, 2, 3, and 4. They add up to about 0.802. And winning not more than 2 games, so not more than 2, not 3 and 4, but everything else is a probability of winning 0, 1, or 2 games. We add those together and we get 0.889. By the way, on tonight's homework, when you're talking about this probability distribution right here, this is a probability distribution with a probability of success equal to 1/3 or 0.3 repeating in a sample size of 4. And on a few of the homework questions tonight, they'll ask you to graph a probability distribution based off of a P and an N. How do you do it? Make a chart like we did here, and then graph every option on your graph. That's a review on how you can graph probability distributions when working with binomial probabilities. Have a great day.